chapter 4. We're talking today, this is going to be day 1 of section 4.4, which is talking about dilations. So let's talk about what a dilation does. A dilation is a transformation that enlarges or shrinks a figure. It enlarges or reduces the figure down. The number that indicates how much larger or smaller the shape becomes is called the scale factor. If the absolute value of the scale factor is greater than 1, then the dilation is an enlargement. It is going to get bigger. So the pre-image will be smaller than the image. If the scale factor is between 0 and 1, then the dilation is a shrink or a reduction. What that means is the pre-image will be bigger than the image. So the figure itself will actually end up getting smaller at that point. We need a center of dilation, the point where the figure is enlarging or reducing from, and we typically use the origin for that. It could change, but for now we're just going to focus in on the origin. So in order to dilate points, we need two things. We need the center of dilation. Like I said, ours will be the origin, and a scale factor. So how do we figure out where it's going to be? Well, given that the pre-image is x sub 1, y sub 1, and a scale factor of k, then the coordinates of the image will be k multiplied to x sub 1 and k multiplied to y sub 1. And that will be the image. And that will automatically change the pre-image so that it's either an enlargement if k is bigger than 1, or it is a reduction or a shrink if it's between 0 and 1. Okay, so let's go through and let's figure out some points. So we're just going to practice this first. So if the pre-image A is at 2, -4, then A prime after this would be at 14, -28. We're just simply going to take the 7 and we're going to multiply it to both. B prime here would be at 3 times 7, which is 21, 5 times 7, which is 35. C prime, again, 4 times 7, which is 28, -6 times 7, -42. And that is going to cause the pre-image to enlarge. And if you notice, those values are quite a bit bigger, which is going to make the overall shape also larger. So here we have a scale factor of 1/2. So this should reduce it or make it smaller, shrink it. So I'm going to take each of these and multiply them by the 1/2. So A prime would be at 3/2, -3. B prime would be at -9/2, 4. And C prime would be at 5, 0. So that's how we actually find our image values for our points. All right, so now let's put it all together. Let's graph it, and we'll go through each of the steps. So I'm going to start off with the pre-image. So -2, 1. Here is A. B is at 1, 1. And C is at 0, -2. Okay, so here's my triangle. This is my pre-image. So now we're going to find the points of the image. So what we're going to simply do is we're going to take those and multiply them by our scale factor of -4. So that's going to give me 8, -4. That's going to give me -4, -4. And C prime would be at 0, 8. So then we come over here, we graph it. A is at 8, 1, 2, 3, 4. Here is A prime. B prime is at -4, -4. And C prime is at 0, 8. Now, when you look at this figure, you might be saying, man, that's a lot bigger. Well, it should be, because what it's saying is it's going to make that figure 4 times the size of the original. Okay, so that's what it's doing. It's enlarging it to 4 times the size of the original. Okay, all right, let's take a look at another one here. So we start off, we're going to graph the pre-image. So negative 8, 4, 1, 2, 3, 4. We have B is at 4, 4. And we have C at 0, negative 8. Okay, so there's my original figure. So now we're going to come back now and find our image points. We're going to multiply each of these by 1/4, so that would be negative 2, comma 1. B prime would be at 1, 1. And C prime would be at 0, negative 2. So what that's going to do is we're going to go negative 2, 1. Here's A prime. B is at 1, 1. And C is at 0, negative 2. And you will notice here, this is going to shrink it to 1/4 of the original size. Okay, let's try another one. Just a couple more here. Let's try this one. Now, when you look at that, 3/2 is bigger than 1. So this is going to cause an enlargement. So we're going to start off negative 2, 6. Here's A. B is at 2, 2. And C is at 0, negative 4. So we connect all of those. Okay, so now we're going to come back. We're now going to multiply this by 3/2. So half of negative 2 is negative 1 times 3 would be negative 3. Half of 6 is 3. 3 times 3 is 9. On B, half of 2 is 1. That would be a 3. Half of 2 is 1. That would be a 3. 0 is going to stay 0. Half of negative 4 is negative 2 times the 3 would get us negative 6. So now we graph our image. So we're going to go negative 3, 9. Here is A prime. B prime is at 3, 3. And C prime is at 0, negative 6. Now, when you look at this, this is basically enlarging it 1.5 times the original size. So notice, not a lot bigger, but it is 1.5 times the original size of the figure. Okay, let's try this last one then. So we're going to start off again with the pre-image. So negative 9, negative 9. Here is A. B is at 9, negative 6. And C is at 3, 3. Now, when you look at this figure, when you look at the scale factor here, this is going to cause a shrink or a reduction, however you like to word that. Okay, the reason being is because that value of 2/3, the absolute value of negative 2/3 is 2/3, falls between 0 and 1. So now let's find A prime. So we're going to do the negative third of negative 9. So that's a positive 3 times 2 would get me 6. Negative a third of 9 is negative 3 times 2 would be a negative 6. B prime would get me negative a third of 9 is negative 3 times 2 is going to give me negative 6. Negative 1/3 of negative 6 is a positive 2 times 2 is 4. C prime, negative 1/3 of 3 is negative 1 times 2 gets me negative 2. Negative 1/3 times 3 is negative 1 times 2. That's going to get me negative 2. So we're going to start off. I've got 6, negative 6. So 1, 2, 3, 4, 5, 6. Down 6. Here is A prime. B prime is -6, 4. And C prime is -2, -2. So when we graph that, and there should be our shape. Okay? And that is how we go about doing a dilation with a scale factor.